Oh, today we are going to talk about a number of jargony looking topics. This is a totally brand new lecture, actually. I've been trying to put this lecture together in my mind for a long time. And this is the day where we're going to try it out. Might be a little rough around the edges, but it's a cleaner version of what this lecture used to be. All right. So I want to talk about two different philosophies for attaining generality. One of them is subtype polymorphism, and the other one's function passing. Okay, so what are these things? Well, we're going to be digging into inheritance, and I'm going to focus on like the practical usefulness of it, the idea that we want to build real pieces of code. And along the way, I'm going to show a contrast between two different, and these are not the only two ways, but two different ways of writing general code. One of them I will call polymorphism, and the other I'll call function passing. Unlike Python, where function passing is really common, in idiomatic Java code, you're going to rely more on polymorphism. And this is not really a programming languages lecture, but you're going to get some of the flavor of what you might see in a programming languages course. So I'm going to jump into Python to show you what these two terms mean in Python. And I'm going to start by talking about how one might try to find the maximum dog in a list of dogs. Now, again, I don't know that everybody here has seen Python, but I know that the vast majority of you have. So I'm just going to assume you have seen it. If you haven't, I think it should be clear because Python's a pretty intuitive language. But on the left, what I have here is this dog class. And dogs have two properties, a name and a size. And then I also have this greater than method. And what this does is it tells the Python language how to interpret greater than between two dogs. So if I have two dogs, A and B, and I compare their sizes, this will tell me that I'm going to compare them based on which ones, like just using their size field. Okay. So this approach right here, this is something called operator overloading. This does not exist in Java. And operator overloading is a form of what is called polymorphism. Polymorphism is sort of a tricky term in programming languages because it's kind of an abstract notion. But what I stole from Wikipedia is it's the ability in programming to present the same programming interface for different underlying forms. So the idea here is that we're using the greater than operator. That's the same interface. The interface is a greater than sign. And then there's underlying forms that the greater than could be. You could be comparing integers. You could be comparing strings or dogs or whatever else. So this is polymorphism. Over here is a function which uses the greater than operator in Python. It gets the maximum item from a sequence of items using greater than. And if I use this get the max on a list of dogs, I will get back the max dog. Any questions about this so far? So what we'll see is Java doesn't do this. That's something else. All right. Function passing is a little more intuitive, I think. That is what you've seen where you pass a key function to, for example, sorted or max or whatever else. In this case, I've written my own max function so I can see what's going on. So in this case, I wrote a function called get the max that takes a list and a key function. And then when you're comparing two items, you first put them through the key function to decide how to compare them. So for example, if I give the key function name length, then it will compare the dogs based on their names. And that's an example of function passing, which is different than polymorphism. Okay. I'm just going to come back to this. Like, I don't expect this to cement it in your brain yet. We'll see examples as we go, and at the end, I'll do a summary where I talk about these examples again. Okay. Any questions about this here? We're past a function, yeah. The double underscore here in Python, it's just it's the name of this magic method, greater than. It has two underscores, just as a point of reminding the programmer that this is something special. Okay. All right. So that's what you knew from Python. Maybe not you. Did you know Python? Have you seen this? Okay. I'm just curious about that. Right here. It's just the name of the greater than magic method. It has the underscores. Yeah.
It's every method that does not appear normally.
Every method that does not appear normally?
Yeah,
I don't
there's
know.
a way to show like a list of all the methods, and anything with
right.
automatically
Ignored whenever you like tab or something in a.
I don't think it's tab. It's like there's a way to like request like.
Oh, I see. You can ask a class what its methods are. Those won't show up. I guess I don't know. I'm not a Python
I think
expert.
it's something like that.
Yeah. So unlike Python, where you'll use function passing and polymorphism, most idiomatic Java code is going to rely more heavily on polymorphism. It's a different flavor. It'll mean that the code feels a little different. And so we're going to spend some time writing those two examples we just showed of getting the max using an intrinsic order and an extrinsic order. And we'll see how the static typing system in Java makes it a little weird. Okay? All right. So let's start writing some code. I'm going to start by talking about something called a comparable. And the example I'm going to have here is I'm going to imagine I have three different dogs here. There's Grigometh, Pelusa, and Clifford. They each have their own size. And here I've created a list of three dogs. Okay, there they are. So I'd like to compare them, and there's two fields we could compare them on, and we're going to start by trying to compare them based on their size. Okay, and in particular, we're going to be writing a function that finds the maximum dog by its size. Okay? Now, the way we would do this in Java, if you were writing real code, using libraries out there, is I would say collections.maxDogs, and so I'm going to pop over to IntelliJ, and we're going to do that. Okay, so if I go into my text editor, here are my three dogs. Let's make this larger. And I uncomment this. Java will yell at me, first of all, because I need to import collections. Okay, I did that. And now it yells at me because, and what this says here is required type collection question mark extends t list dog. It's hard to read, a strange message. And I have it on the slide here. So the problem is that Max doesn't know how to compare two dogs. It doesn't know what makes one dog bigger than another. If I go to the dog class, I mean, that makes sense. Like there's two properties here. So how would collections.max know which one to select? Okay. The size is what we want, but it doesn't know. Okay. So we want to try and tell it that what we want is size. Okay. So unlike Python, where we would rely on operator overloading, we'd overload the greater than operator. In Java, we have to say, first of all, that a dog is something that could be compared. And then second, how to do the comparison. So question, in Java, how do we specify that a class has a certain capability? Yeah? A method, yes, but we want to specify to the compiler. We want to tell the compiler that dogs can do this thing. I'm going to take it back of the room, yeah. Interface inheritance, right. So we need to have an interface that says this thing can be compared to other things, and that is something in Java called a comparable. Okay. So in Java, if you want to say something can be compared, which is quite different than Python. In Python, there's a greater than operator that anybody can use. But in Java, we have to use this specific interface called comparable. Now, most of Java is written in Java, almost everything. And as a result, we can actually go look at comparable.java to see how it's declared. Okay, so I'm going to go to the actual source code of the Java programming language. This is the current version. And this is comparable.java. So you'll notice that it's mostly comments. Some of it's just like copyright stuff. There's some package statements. We haven't really talked about that much. There's an import statement, lots and lots of comments, public interface comparable T, and then there's one method, which has no body because it's a abstract method. We haven't said what it is, okay? So that's comparable. And basically what it says is any class that implements comparable has to provide this method. I'll show you the slides version though. So if you ever want, you can go browsing Java and most everything you can find. Like one thing I know that's not in Java is array copy. That's written in C++. But almost everything else is in Java. So this is the interface. And what you'll see if you look at the whole thing, it's 142 lines of code, but there's only 3 real lines of code. There's public interface comparable T, there's public int compare to, and then there's a closing bracket. And almost all the rest is documentation, and that's common because this is something really important to Java. So you want to make sure that people know exactly what it does, and there's other details there, but this is what we care about. We've seen this before. Returns a negative integer, 0, or a positive integer, as this object is less than, equal to, or greater than the specified object. Okay. So we need to implement this interface. Any questions about this so far? Okay. So let's do that. I'm going to go into my dog class, and I'm going to say implements comparable dog. So this is basically telling the world dogs know how to compare themselves to other dogs, and now I get a squiggly line. Why? Say again? Not equal, compare to method, right? No compare to method. So what we need to do, I guess, let me see if it'll, okay. Implement method. So I'm going to push this button, and I'm going to implement it, and there you go. It created a default one for me. You'll notice it put override here. And again, that's because that's what we usually do to avoid typos and also to remind ourselves that it is an overridden method. I'm actually going to put the name Uttadog for a good reason, so I can tell a story. So I want to compare two dogs, and I'm going to compare them based on their size. So I'm going to do the following. I'm going to say if size is less than Uttadog.size, then return -1. Else, if size is greater than Uttadog.size, return 1. Lastly, we'll return 0 because the only other possibility is they are the same size. Okay. That's Uttadog. The reason I picked Uttadog is a long time ago, I was at Ehu and Kai renting a kayak on the Big Island. And Ehu and Kai is named after this guy. I don't remember which one's the dog and which one's the guy. I'll say Ehu is the guy and Kai is the dog. And he had 2 dogs. And it's the name of his business. Let's go to his website. Ehu and Kai. I went there earlier. Here you go. So they'll rent you kayaks if you want to go to Kealakekua Bay. It's a great place. And it's named after his dog. And I was like, well, who's the other dog? And he said, Dada dog. So anyway, that's why it's good. I recommend them for kayak rentals. And I also recommend Kealakekua Bay. In fact, I'm going to tell you guys a secret. Not the secret of who's buried there. Kealakekua Bay. There you go. All along this stretch of land is lava zone. If you kayak across and there's a nice west swell, there's just the most insane set of little water channels here, like blowholes, all kinds of stuff. It's the most amazing thing. So if you're ever on the Big Island, it's very cool. It's unbelievably awesome when the waves are big, just water shooting through all the most insane channels of all time. Anyway, that's not very important. What is important is inheritance. Who here has been to Kealakekua Bay? Yeah? Yeah, okay. Actually, one more tip. Somewhere over here, it's somewhere by there's a place around here, somewhere around here where you can kayak, and then there's a place where you can put a kayak and then crawl inside of the wall, and there's a cave, an old lava tube, but you can only get there by sea. It's very cool. It's one of the coolest places I've been. It's just like a hole in the wall of this cliff, and you can go pretty deep, and it feels like a place no humans should be, but it's great. Yeah. How was the kayak? They're not that expensive, the kayaks, especially if you're making money as a programmer one day. Yeah, but highly recommend it. I mean, just kayaking around the west side of the Big Island. It's good. All right, I will give more Big Island tips some other day. But Big Island's #1 island. All right. I used to live in Oahu for a while because I was just there surfing every sunrise and sunset for a while. All right, anyway, enough about me and the Big Island. So we've written the compare to method here. Okay. Now that we've done this, our dogs can be compared. And if I go back to my demo and I run this, let's see, I'll do the debugger. How about that? That was too much anecdote. Anyway, you can yell at me on the course evaluations. So anyway, after I run this line of code, I'm going to step over one. Max dog will point at the biggest dog, the largest one. So see, max dog actually worked. All right, any questions about this so far? No. Oh, yes. Right. So we can't see the max method, but somehow it knows, whatever its code is, that if the number is less than, that means less than. And so if the number is negative, it means less than, and so forth. So it knows, whoever it is. Okay. Another way to implement this code is shown on the slide. I'm actually going to go into the IntelliJ to do it more nicely. Because we only need to return a negative number if our size is less, we could just do size minus Uttadog.size. And that's what a normal compare to method usually looks like. Because if my size is 3 and your size is 50, subtract those, I get -47. It's less than. Incidentally, this is why the contract is as it is. The reason that Java says that compare to returns a negative number if you're smaller is they know that compare to methods are going to be written like this. It's pretty clever. All right, any questions? Yeah.
If you implement multiple interfaces at the
Like say you wanted, oh, if you wanted to have multiple interfaces, yeah, you absolutely could. So I could do like, we'll talk about this one on Wednesday. So I could say iterable dog, and that's fine. Then I just have to add those methods. Yeah. Other questions? Is that my phone doing anything? I don't know. If you're getting text, that's okay. I'm not upset. All right. Now, if I were to print the max dog, if you try it later, you'll get weird output. You'll just get random garbagey strings, and we'll talk about that in the next lecture. But for today, I just showed it in the debugger. So what we just saw is what's called subtype polymorphism. There's some supertype that says what you can do. In this case, it's comparable. And it says what you can do is be compared. And then some subtype overrides the abstract method provided by the supertype. And so Java will decide what to do at runtime based on the type of the object that's invoking the method. This is something sometimes called dynamic dispatch. It is beyond the scope of our class. Sometimes it used to be part of the class, but I don't talk about it as much now. Okay. Now, this is very different than Python, where there's this common sense of a greater than operator. Try that. That anybody can overload. Okay. Different flow. All right. So now I have a puzzle for you to see if this makes sense. This is the interesting question always. So in this little puzzle, I'm imagining a universe where we have dog launcher, the class. Oh, I should not make called maximizer. Oh, okay, sorry, I busted myself here. I should say collections.max. Let's make this, there we go, that's good enough. And we'll fix the next one real quick too. Okay, I revised, as I said, this is a new one. I apologize for any roughness today, as this is new. Okay, so imagine that I have these files, dog launcher, which creates an array of dogs and then calls collection.maxDogs. Then I have a dog class, which implements comparable dog. And then I have collections, which we've never seen in the code, but we know that somewhere it's making comparisons. Okay. In fact, this really should see arrays, but I'm just going to say collections. Oh, no, I'm going to fix it. Okay, I'm going to pretend that this function is part of collections. Okay, that's the better solution. You need access? Okay, thank you. Okay. So what I want you to tell me is if I were to delete compare to, which file will not compile? Okay, so we're going to open up, oh, it's under my other Gmail or my other drive. Okay. Get published, managed. Okay, now you can do it. And now you can see the question. Okay, so I'm gonna give you guys like a minute and a half to think about this question. So what I'm doing is I'm deleting compare to, but I'm leaving everything else as is. Take a minute and a half to think about it. Guess which one will not compile. Recall that compilation happens before you run the code. Sorry, I talked about Hawaii for too long. Sorry, I talked about Hawaii for too long. Yeah. 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 Right. Yeah. I'll get to you. I've done the next question. Okay. All right, everybody. Okay, so we're at about 50% correct. I'm going to start with, I'm just going to pick collections.java. Someone give me an argument for why collections should not compile. I'm gonna throw out an idea. Even if you didn't pick collections, you can give me an argument. Anybody? Make an argument. Yeah, go for it. Right, you're trying to call compare to, but there's nothing there. It's an interesting thought. So that, I think, that is a reasonable way to think about things, but the reason that's not the correct answer is that compilation happens before the code runs. So you're imagining a world where like collections is about to do the comparison, it's reaching for the comparison function and it doesn't exist, and then you crash. So it'd be like a runtime crash. And that's something that would happen to you in a language more like Python, but it won't happen here because the compiler will get upset. Another way to think about this is that the collections.java file was written by somebody at Oracle or Sun at something like 25 years ago. And what you do today doesn't affect whether their code they wrote in the year 2000 will compile or not. In fact, this collections file, it's been sitting there a long time. So you making a new class, dog, won't make collections not compile. Okay, someone had another thought over here, I think. Yeah. Go ahead. Right, the red lines appear here. So if we go into dog and then we delete the compare to method, it's dog that's the problem. The compiler says, dog, you claim to be comparable, but you don't say how to compare. You are dead to me, right? Like you're not obeying the contract. So indeed, the correct answer is dog. Dog is the one that doesn't compile. So if you thought it was collections or comparable, just remember that those two things exist independent of dog. They were there before. Yes. Okay, everyone, yeah. Yeah, if you implement an interface, you must implement every method. Otherwise, you're not doing what you claimed you can do, right? Yeah. You're claiming that you're an architect, but you don't know how to draw or whatever. Like you're just, that's not okay. All right. There's another one for you. So let's suppose instead, and we'll see if this one, let me know if I need to fix the permissions on this one. Showing up? No, okay, let's fix it. I was trying so hard. Okay, so this one, we'll fix them both. Okay. You would think by now I'd remember to do this every time. Maybe I can blame Justin somehow. I don't know.
Oh, by the way, they really liked your Hawaii.
Oh, they liked my Hawaii anecdotes? Okay, good. All right. We'll have a Hawaii day. How about that? We'll just talk about Hawaii all day. Anyway, all right. So imagine now what I got rid of. Oh, that's not very clear visually. There you go. That looks better. All right. Imagine we got rid of implements comparable. Who will not compile?
Either way, don't do this.
All right. This time we're closer. We felt like it's either dog or dog launcher, most of you. I want to reiterate that if you thought it was collections or comparable, keep in mind that those interfaces existed before you wrote dog, and therefore they should compile. Because Java, when it takes an existing class, it'll just build its .class file. It happens before any code ever runs. You can compile these things even if dog doesn't exist. So now it's between dog and dog launcher. The argument for dog would be, well, you gave a compare to method, but you didn't actually say you're comparable. Like you can draw, but you're not an architect. And that's actually okay. So it's not dog, it's dog launcher. In particular, let's just do it real quick. If I go in here and I take out implements comparable dog, well, override won't work. Okay. So I guess dog is true too, but it wasn't on the slide because I didn't say override. So if you pick dog, I'll give you a thumbs up. If I delete override though, now the real problem will be in this class. Because even though dogs has a compare to method, the compiler, it's not like Python where it's duck typing. If you have the method, it'll get called. With Java, you have to officially, formally state, I am a comparable, I am an architect, whatever it may be. Okay. So I guess what I would say is either dog or dog launcher is fine, but I like dog launcher slightly more. Yeah. Say again? The dog class, I'll make a little note here on the slide. If we used override, dog will not compile because we have an override tag, but we're not overriding. If we didn't say we weren't, we omit implements comparable. Okay. All right. Okay. Hopefully you're happy with that answer. It's a little murky. Murky answers are better than clean answers, though, because now you have to think about it and argue. Yeah? No, okay. Yeah. Yes. Right. Yeah. That's why I like the dog launcher answer better, because the override tag's technically optional. Go ahead. One sec. In Python?
The difference between like if this was a Python, which class would throw an error instead?
I don't want to think about that right now. Ask me right after, but I feel like it'll take too much momentum to explain the question to the room and then figure it out.
I think it probably wouldn't error at all.
Python might not error, but Python, if you don't override the greater than operator and you try to call it, it'll exception at runtime. Yeah. All right. Let's talk about comparators. So the term natural order is sometimes used to refer to the ordering implied by your compare to method. Okay. Oh, by the way, this little problem, there will be a discussion worksheet question similar to this, so you get more practice with it. This is a tricky thing in this class. Anyway, so comparators, the term natural order, as I just noted, it's the order that is natural to the objects. In this case, it's the size comparison, because that's what we said dogs compare themselves based on, right? So we say they have a natural order based on their size, but maybe we want to sort them based on their names, right? So how would we do that? So it is not the case that you go into your dog class and then give more compare to methods, which you can kind of imagine. That's not the way that Java does it. Instead, we're going to use something called a comparator. Before I get there, let's talk about the Python approach. So in Python, we did this using function passing, where we would pass a key function. And then when we call get the max, we'll use that key function to decide what makes one dog bigger than another. In this particular case, to make the function a little more interesting, I had it return the length of the dog name, though in our running example, it'll be the alphabetical order. Sorry for the slight mismatch in idea, but I think it makes it easier to understand the Python code to make this a little more complicated than if I just did return dog dog. Now, the difference is that Java, rather than using function passing, is going to use subtype polymorphism. And in particular, we're going to use an interface called the comparator. So this comparator interface has one method that we care about, and it takes two parameters. One is the first object I want to compare, and the second is the second object. So let's try building and using one of these for dogs. That's going to be based on the name. And in this particular case, I'm not going to actually open the official comparator.java because it's surprisingly complicated. So if I want to have here a new comparator object, I'm going to make a nested class. I'm going to say public static class name comparator, and it's going to implement comparator dog. Okay, implements. I need to import the comparator class. And then once I do that, it yells at me and it says, you're missing something. In particular, you are missing the compare TT method. I know it's very tiny, but I'll just do the usual shortcut. Okay, so here's my compare method I need to fill in. Nope, not all that stuff. Then I have two dogs. I'm going to call them A and B to match the slides. And then I'm going to do what? How do I compare them by name? I'm going to do like A.name. Compare to B.name. Great. I'll just use the string classes compare to method. So I don't have to think about comparing strings. However strings compare, great. We'll do that. Okay. So that's this name comparator idea. All right. So at this point, I've written a name comparator that I can use to compare dogs based on their name. You'll notice that this is not a method of the dog class itself. It's another class. And by the way, it doesn't need to actually be in this file. I could have made this a separate file called namecomparator.java. I did not, you don't have to have the override, but it's a good idea. Okay, third question of our day. And this one I think should work right off the bat. What do you think will be the output of this code? If I create a dog Frank, a dog Zeke, and then I do out println nc compare a comma b, just to double check that this is making sense. So I've made one of these objects, and then I'm asking it to use its compare method. Uh-oh, is the wrong question? Ah, hold on. Well, you're answering randomly. Okay, that makes sense. All right, I'm just gonna make this one. Oh my goodness. See? Okay, we're gonna turn this into an open question. It's not a purple one. Ignore this thing. We're gonna do this instead. Okay, somebody want to throw out an answer since I put the wrong poll question in? What do you think? Yeah? Negative number, right? So what it's going to do is it's going to say Frank is less than Zeke. Okay. How do we know that? Because this name comparator object told me. Any questions about the structure of the code on the slide? Yeah. I don't want to talk about string compares. Oh, link. Oh, it doesn't compare the links. It does alphabetical order. Yeah. Yeah. Oh, so if you thought it was link, then I guess you could have thought it was positive. All right. Okay. So that's the natural order for strings is alphabetical. Okay. So at this point, what we could do is we could use our name comparator to find the dog with the maximum name, where it would be collections.max dogs, and then I pass in this name comparator object, and I would get, in this case, Palooza. By contrast, if I use Python, it might look something like this. And notice in this case, I was using the length of the name rather than the alphabetical order. And again, I know that's slightly annoying, but I decided it was a better choice. Maybe I'm wrong. Yeah.
We get before this particular system.
The max? Why? What's the name? Yeah, it's alphabetical order. Yeah. So you'd get Clifford. I mean, sorry, you would get Palooza. Yeah. Right. So the second argument, this is a great question. What is this argument here? It's an object of type what? Back to you. In fact, I'm gonna edit the slide here. Yes, so this second argument is an object of type comparator dog. That's what I was going for. This one here. I'll make it red, and maybe it makes it visible. Okay. Makes sense. So collections.max can take two arguments. The first argument's the thing you want to find the maximum of, and the second is a thing for comparing. It's kind of like in Python, you give it the list of dogs and then the function you want to use to compare. Make sense? A different way of thinking about this is that in Python, we pass the functions directly. In Java, we package the comparison function inside of a comparator object and then rely on subtype polymorphism, which is basically saying whatever that type does to compare, we'll trust it. Yeah. So why do this rather than making the dog itself comparable? Great question. Somebody? Yeah? Yeah, you want other ways, multiple ways to compare dogs. Yeah. So you want to do something other than the natural order. Okay. So one thing that I don't like so much, you might have also sort of like, when looking at this code, I think you already just had this like hair-raising feeling. Like it feels strange to do this, to be instantiating this comparator right here. If you don't like that, one fix is to add a static variable to this name comparator inside of the dog class itself. So I'm going to show you that real quick. This is actually pretty common in Java code. Like I don't want anybody to ever actually like bother to call this thing. And instead I don't, okay, I'm gonna try this one real quick. Private, I'm gonna do public. Hold on, hey, oh no.
Hello?
We just got a little spinny boy.
Oh.
How's Zoom doing? Am I still visible on Zoom? I'm moving? Oh, good. Okay, so it's just IntelliJ that's crashing. All right, we're gonna kill it. Bye, IntelliJ. Hey, you can come back, IntelliJ, after you thought about what you did.
41 hours.
All right. Oh, okay, that's pretty good.
Kind of explains it.
All right, where were we? Okay, so I was showing you how you could do something like public static comparator dog name comparator equals new name comparator. Now it might feel like I'm just, what on earth are you doing, Josh? The idea is like, I don't want anybody to have to make one of these themselves. And then when I write code, I will instead pass in something like name comparator, dog.name comparator. Okay, and that's fine. Any questions about that? Like, does this feel better to you than new dog name comparator? I don't know, but you can do it. Collections does not require that. So that's a good question. If I delete this, what order do you think it uses? The natural order, whatever is in the comparable. Yeah. There's a bonus slide. There are lambdas in Java. So you can define comparators on one line. I will not teach this, but here it is for those of you who want to do it. Okay. All right. So I want to talk about comparables versus comparators. This is the most important thing to understand what you need for Project 1B, the midterm, and I think writing Java. So the comparable interface specifies the natural order of things. It says that there's a natural order, and it means that dogs can now compare themselves to other dogs. And only one such order is possible. By contrast, comparators are used so you can define other orders, and those are done by other objects. For example, name comparators, size comparators, speed comparators, or others. So any questions about this? Yeah.
Can you put up the slide for a second?
Yeah, please. Yeah. And in Python, the top approach is done with overloading a greater than, and the bottom is done using a key function. Just a different flavor, different idioms. Yeah.
So an object is not comparable, it can still be compared using comparator.
Right. Even if an object is not comparable, it can be compared using a comparator. That's nice. Little tune. Okay. Let's talk about one last kind of annoying thing, which is how would we write our own max function? So the important part is that you understand this. This is what you're going to do in life. But in the real world, someone has to write the max function. So I'm going to give you just a little flavor for how that's done. And you'll get to do it a little bit on Project 1B as a small exercise at the end. So we know there's this nice collections.max function, but there's other functions like min, reverse, sort, and all of these functions are able to use orders to do useful tasks. So I'm going to show you how to write such functions, and I'm going to start by showing you some of the pain that comes with a static typing system. Okay. So let's suppose we want a function, just for the moment, that picks a random item from an array. Here's what some such code might look like. Okay. So you give me an array of strings. I create a random, whatever that is. Then I pick a random integer between 0 and 1 minus the length of the array. And then I return that item. This is how you would pick a random item. Okay. Fine. And then as one way we could use this class, we could create an array of 3 strings. And we could say pick high, little, or cat. Okay. Now imagine that we wanted to take an array of anything. Okay, so how could we do that? Well, one approach would be, let's try and use our generics idea. So I'm going to do like bracket t, static t, pick random t. And I'll just tell you first that this code won't work. Java won't compile this. Anybody have a philosophical reason why it shouldn't compile? Yeah? Static, something static-y, right? Like that would mean that a random picker, you need to instantiate it and then call pick random and use its type. But there is no specific random picker. Like a random picker static method, it doesn't make sense, really, to me. That's kind of an advanced thought. But it doesn't make sense because we would need to instantiate a random picker to pick the type using the bracket operator later. But then we don't invoke a static method using an instance. Okay. So I could work around this by saying, okay, I'm changing everything. I'm going to make it a non-static method. And then when I want to pick a random thing, I'll make a random picker that's of, say, type string. Ooh, this should be strings. Sorry, I changed something earlier. Let's fix it to avoid confusion. It's worth it. There we go. It's almost aesthetically nice. So if I do this approach, this will work technically, but again, it doesn't feel nice to me that I need to make random pickers. Like, then I have to make a new random picker for every type I want to pick randomly from. I don't know. I mean, you can do this, but it's not as nice. Any questions or thoughts about this? So using what you know so far, you can make it work. But let me show you something super annoying, which is how it's actually done. Okay. Oh, sorry. This is busted again. Okay. Now, this is just basically what I said out loud. You can do this, but it's kind of ugly. This is the way that it's usually done, which is to make the static method generic. Okay. So what I'm adding here, the difference is I'm saying public static, and then here's the little bracket with the T. Okay. I put the word after the word static, and I know this is confusing, and this is an advanced topic that's just barely in scope in 61B. You're only going to write a tiny bit of code like this. And I've never taught it before in 61B, and the TAs probably don't know it, so be patient with them. But basically, the way you should read this is, I am declaring a public static function that works on objects of type T. That's what this part is here. It returns a T, and it's called pick random and so forth. So this little thing right here tells you that this is a generic function. Okay, now this is a lot to digest. I know, like you've gone from never heard of inheritance in Java last Friday to this. So I'm sorry, but I thought you might find it interesting. For now, though, you should just think of it as syntax that you have to put in there for the compiler to be happy about. Okay. Once you add this magic set of 3 characters, now it works just fine. Okay. All right, any questions about this other than, I guess I'll learn that when I do project 1B. Yeah. We don't have to make an instance of random picker in this case. So this static method is generic. And then Java's smart enough to realize that when you call pick random, these are strings, and it fills this in for you. Yes.
Use this by just making every single function generic.
Can we abuse this by making all functions generic? It's an interesting question. Why not do this for every function you write?
Not everything wants to return an arbitrary thing.
Yeah, not everything wants to return an arbitrary type. Sure. I mean, it's an interesting question. If you think about all the other functions you've written in this class, like for 2048, if you throw in that T, does that cause you trouble? I don't know. Yeah. Other question behind you? Oh, same question? Yeah. A good question I'll ask next time when I teach this lecture again, and I've cleaned it up, Because I will give a function right after this and say, why not do this? I'm sure there's a good reason not to. Yeah. Right. So making the whole class generic, the question was, why not do that? Then you have to instantiate that class in order to get that kind of generic behavior. But here, by putting this in the static method signature, you don't have to instantiate. Yeah.
Oh, yeah.
It's a way of getting generics with static. Yeah.
Could you also, instead of T, just put object?
Could you put object?
Yeah.
You could, but then whenever you try to assign like X equals random picker dot pick random, then you would not be able to put it into a string variable. Yeah. Now, one extra annoyance is that our pick random function will not work with integers. Like if I try it with integers, it'll yell at me because an array of integers is not an array of t's. So this is, again, now this is like out there at the very edge of knowledge that you care about. Java, because primitive types are not reference types, if you go and look at like arrays.html, or if you look at arrays, the arrays class, it actually has many different, say, sort methods. And this is such a dirty feature of Java, but there really is a separate sort method for integers, longs, shorts, characters, bytes, doubles, and so forth. And that's one of the things that Project Valhalla is trying to fix, is not have this big gap between reference types and primitive types. Yeah. Yeah, capital I integer is fine, but lowercase int, not so much. Okay. All right, I'm going to show you one more thing. I feel like I did too much stuff today. That's what I've learned, but that's okay. We're gonna finish off, and I will clean up the message and shorten it next time around. Thank you for being my guinea pigs. So the max function, if we try and write our own max function, we know it's going to look a little something like this. We need it to be some generic type. And if we fill in the code, I mean, it's the same pattern as usual. First, we say the max item is 0. Then we iterate over everything. If the item is bigger, then we'll set max item equal to items. But if we do this, what do you think will happen? Like Java will get mad because what? What does it not know about T? If it could be compared. And in fact, it doesn't know if T has a comparison function. And this is the extra final little piece of magic syntax I'll tell you, is you can tell Java, you know what? I don't want just any type. It has to be a type that is comparable. And this is as dirty as I'm going to get with a generic system. Okay. So I can say, I don't want just any T. I need a T that is actually comparable to T. Okay. This is why static typing gets very messy and why people like Python, because if you're writing library code, it looks like this. Okay. All right. But basically the idea is we're specifying, like, I won't take any type. You can't give me something that's not comparable. It has to be something that is declaring itself comparable. Okay. Now, there's more. The bad news is that this actually isn't what the library functions look like. They actually look like this. T extends comparable question mark super T. And I'm not even going to get started telling you what that means, but I'm happy to talk about it in office hours. The message here for you is that in practice, when you're using a language like Java with the static typing system, the people that write the libraries have a lot of pain. Yeah, I want to talk about the summary though, because I've taken you out to the limits. Like I showed you the abyss beyond reality. But what I do want you to understand is this. Come on, simmer down. So we've seen polymorphism and function passing, right? We saw that in Java, we use subtype polymorphism where Python uses operator overloading for natural orders. When we wanted to have multiple orders, Python uses function passing, but Java again uses subtype polymorphism. It's the tool that we use for everything. And the very last thing we saw is that if you actually want to write code that uses comparables and comparators, it is quite messy. You'll get some practice on Project 1B, but the good news is your code's mostly going to look like this and not like this. All right, that's all I got for you guys today. Thank you, and I'll see you on Wednesday.